Hello, today let's look at Polkadot's architecture and also how Polkadot's powerful cores will be utilized. Polkadot is a heterogeneous, scalable, decentralized multi-chain with shared security and interoperability. All that sounds very complex, so in order to truly understand how Polkadot block space ecosystem works, it's needed to examine individual elemental parts of Polkadot's architecture and mainly Polkadot's cores. First, Polkadot relay chain. The relay chain is the central chain of the entire Polkadot ecosystem. Relay chain has deliberately somewhat minimal functionality, so on the relay chain you can create an account, hold DOT, transfer DOT from one account to another. You can stake your DOT both in the open graph or transfer DOT from the relay chain to Parachains via XCMP channels. Polkadot relay chain also doesn't support smart contracts. The main responsibility of the relay chain is to coordinate the entire ecosystem as a whole and provide shared security and consensus to all parachains. Moving to Polkadot's cores, ultimately the main purpose of the Polkadot as a supercomputer is to serve as a robust, unstoppable computational resource. In the current form with 50 cores, Polkadot supercomputer is already several times more powerful than standard computers, which usually have between 4 to 8 cores. According to Gavin Wood, over the next few years, Polkadot will scale up to hundreds of cores. Each Polkadot core is like a core on a processor. It does computation and executes tasks. So each core is continuously operating, running one process at a time, independently of all other Polkadot cores. Polkadot allows these cores to be used using two subscription models, Parachains and Parathreads. Parachains have a dedicated core on Polkadot relay chain, so each parachain deployed on Polkadot utilizes one core. With the recent introduction of core time rentals, Parachains will purchase core time via bulk core rentals for 4 weeks. So thanks to operating on a dedicated core, Parachains are blockchains that are constantly operating on Polkadot relay chain. Hence, Parachains can be viewed as processes that run constantly. And here allow me for this slightly bullish analogy for Astar and Polkadot. Last year, Astar announced it's aiming to become an app store of the Web3, similar to what Apple's App Store is in Web2, and also Polkadot, with its ability to scale up to 1000 parachains, can also become a whole new kind of app store for application-specific blockchains. Speaking of Apple, look at Apple's slogan they used on the App Store, the apps you love from a place you can trust. I mean, Apple uses the biggest weakness of the Web2, the need to trust, to promote the App Store. For me, that's unbelievable, and I'm sure it also feels ridiculous to all true Web3 believers. This only illustrates on what values and fundamentals the entire Web2 is based on, a need to trust. Unfortunately, most internet users still think it's totally okay having to trust third parties. That's why educating about the Polkadot and Web3 is so important. The other way to obtain core time on one of Polkadot's core is Parathreads model. With Polkadot 2.0, Parathreads model is shifting into instantaneous sales of core time for immediate usage. So Parathreads can be viewed as processes that are running only during certain time periods. So using that analogy of Polkadot being a supercomputer, Parathreads are processes that are woken up only occasionally, whereas Parachains are processes that run constantly. Another fundamental part of Polkadot's architecture is consensus. Consensus is basically a method using which validators come to an agreement over a state of the Polkadot relay chain. In general, in order for any blockchain to continue generating blocks, all nodes in the network must agree on the current state of the blockchain and come to a consensus. So consensus is the way how all Polkadot validators are able to stay synced with each other and agree on the shared state of the Polkadot relay chain. Consensus leads to building new blocks on Polkadot, which subsequently causes the state of the Polkadot relay chain and all parachains to be updated. And Polkadot uses nominated proof of stake consensus, where DOT holders nominate their DOT to validators. And so consensus is taking us to the main participants on Polkadot, which are validators, nominators and collators. Validators have to put their DOT at stake in order to run a validator node so that they get into active validators set. Above all, validators produce blocks on the relay chain, plus they also collect proofs about valid parachain state transition from parachain collators. And in return for all this work, validators are rewarded with DOT generated by Polkadot's inflation, which is around 10% annually, and the remaining DOT from inflation, which is not used to reward validators, goes to the Polkadot Treasury. Validators bring us to Nominators. As I said, Polkadot uses nominated proof of stake, which is different from standard proof of stake by that it allows DOT holders to nominate validators and back them with their DOT. And lastly, there are also Collators who collect transactions executed on Parachains, and then they produce a proof about the state transition of that particular parachain for the validators on the Polkadot relay chain. I know some people still wonder why parachain collators are needed when parachains are secured by Polkadot's shared security, which is ensured by Polkadot Validators set. Well, collators collect transactions and produce blocks on parachains, whereas relay chain validators verify the validity of these blocks produced by collators. So this was Polkadot architecture in a nutshell. If you like the content, please give the video a thumbs up. Thanks for watching and I'll see you next time.